Welcome back to Algebra 2 Priority Standard 6. We are studying here some different rational functions. These are functions that can be written as fractions or ratios. And our learning target today is to write and solve an equation for inverse variation. So this is a particular example of a rational function that has a lot of different real-world applications. So first off, let's just look at a few different examples. And if you'll notice the equations that we're going to be charting here, they all have very similar formats. Y equals 4x, y equals 12x, and y equals 8x. In general, all of these different equations have the form y is equal to some constant, we'll use the letter k for the constant, times the x value. So if I fill out this first chart, y equals 4x, so it's going to be y equals 4 times 0, which is 0, 4 times 2, which is 8, 4 times 4, which is 16, 4 times 6 is 24, and then 4 times 8 is 32. If I fill out the next chart, y equals 12x, 12 times 0 is 0, 12 times 1 is 12, 12 times 2 is 24, and then we have 36, and 12 times 4 is 48. On the last chart, we have y equals 8x. 0 times 8 is 0. 8 times 0.5, or 8 times 1/2, is 4. 8x, 8 times 1 is 8. 8 times 1.5 is 12. And 8 times 2 is 16. So the pattern that you'll notice in all of these charts is that as x is getting larger, the y value is also getting larger. And these are all examples of direct variation. That's a vocab term that you may see in chemistry as well. Mass and number of moles is an example of direct variation. As you have more moles, you also get more mass. Volume and number of moles. As you get more and more gas particles, they take up more and more space. So all of these different direct variations, as x gets larger, y gets larger too. And as I pointed out at the beginning, all of these have the same format. This is y is equal to some constant times x. And any direct variation function is going to have that exact same format, y equals kx, just with different numbers plugged in for k. And what kind of equation is this? These are all linear functions. You might recognize the form better if I added on a plus 0. Y equals 4x plus 0. That's y equals mx plus b form. These graphs are all going to be straight lines. So that's direct variation. But now let's look at some other equations. These ones all have the form y equals some number divided by x, or in general, y equals k divided by x. And let's see what happens when I fill out these charts. So the first one, y equals 4 divided by x, would be 4 divided by 0. That's undefined. We learned that in our last lesson, that dividing by 0 does not give us an actual number. 4 divided by 1 is just 4. We can do that. 4 divided by 2 is 2. 4 divided by 3 is going to be a fraction, so I'll just do that in my calculator. It's 1.33 repeating. 4 divided by 4 is 1. 4 divided by 5 is about 0.8, 0.8. And 4 divided by 6 is 2/3, or 0.66 repeating. This next example, y equals 24 divided by x. Again, any number divided by 0 is undefined. And then going down the list, 24 divided by 1 is still 24. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 24 divided by 5 is going to be a fraction, that is 4.8. And 24 divided by 6 is 4. And our last example, y equals 30 divided by x. Again, 30 divided by 0, any number divided by 0 is undefined. 30 divided by 1 is still itself. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 divided by 4 is 7.5. 30 divided by 5 is 6, and 30 divided by 6 is 5. So all three of these functions are examples of inverse variation. Because as x gets larger, notice what happens to the y values. We are going from 4 to 2 to 1. In the first example, from 24 to 12 down to 8. Or in the last column, from 30 to 15 to 10. As x is getting larger, y is getting smaller. So in real life, you'll have lots of examples of this as well. As pressure increases, the more you squash something, volume decreases. The more you squash something, the less space it takes up. So these are all having the form y is equal to some constant divided by x. And this fits into our priority standard 6 because these are all rational functions. A rational function, the purpose of this whole unit, these are equations that have a variable in the denominator of the fraction. So when we have k divided by x, there's x in the denominator. This is a rational function, so we are studying it here in PS6. So what do you need to do with these rational functions or these direct variation linear functions? Is we're going to write specific equations. So this first one says, given that y varies inversely with x, and that when y is 10, then x is 3, write a function that represents this. So the first thing you're going to need to do is decide what format to use. Is this direct or is this inverse? And this tells us y varies inversely with x. That means it has the format y is equal to some constant divided by x. And in order to write an actual function here, we need to figure out what the constant is. So we're going to plug in the numbers that we know for x and y and figure out what my constant is. So I'm given that when y is 10, then x is 3. So I'm going to plug that in. Y equal 10 equals k divided by 3. And then to solve for this constant, I would sort of cross multiply. I'm going to multiply by 3 on both sides. So that instead of dividing by 3, I cancel that out and multiply by 3. So 3 times 10 is, of course, 30, and that's equal to my constant. This would be my inverse variation constant. So y equals k over x. I know now that k is 30. So my function is y equals 30 divided by x. In my next problem, I have that y varies directly with x and that y equals 45 when x equals 5. So since this one represents direct variation, I'm going to use the correct format that all direct variation equations have, is y equals k times x. So inverse variation always has the form y equals k divided by x. Direct variation always has the form y equals k times x. And our step is still the same. We need to plug in the values of y and x that we know to figure out what the variation constant is. So y is 45. That's equal to kx. And we know that at that particular point, x is 5. So 45 is equal to k times 5. So to get rid of the 5 and figure out what k is equal to, we'll do the opposite of multiplication by 5, which is dividing both sides by 5. 45 divided by 5 is 9, and that's going to equal my constant. So I know that y equals k times x. If k is 9, then my equation becomes y equals 9 times x. So your overall problem-solving process is going to be to choose the correct function format, whether it's an inverse equation, y equals k divided by x, or a direct equation, y equals k times x. Plug in the numbers of x and y that you're given and use those to solve for k in the equation. We'll do two more examples here. First of all, we're given that y varies directly with x and that y is 24 when x is 3. So if I have direct variation, that has the form y equals k times x. Plugging in the x and y values that I'm given, I know that y is 24, and that's equal to k times the x value of 3. So instead of having k times 3, I'm going to divide both sides by 3 to undo the multiplication. 24 divided by 3 is 8. So I know that my variation constant is 8. So y equals k times x becomes y equals 8x. And they want us to do a little extra practice here plugging numbers into the equation. So it says when x is 0.5, what is y? So we're going to use this equation that we just came up with, y equals 8x, and see what we get if we plug in x is 0.5. So y equals 8x becomes y equals 8 times 0.5. So the y value or the function value when x is 0.5 is 8 times 0.5 or 4. One final example here for this learning target. We're given that y varies inversely with x, and that when x is 4, then y is 8. So this is an inverse variation function. That means that it has the format y equals k divided by x. And in this problem, I know that when x is 4, y is 8. So plugging in those numbers, y is 8, that's equal to k divided by x, but I know that x is 4. I'm plugging in the number 4 here for x. Now to get k by itself, I need to do the opposite of what is currently being done. So right now we have k divided by 4. The opposite of that is going to be multiplying both sides by 4. So I'm going to multiply both sides by 4 to solve for k. 4 times 8 is 32. So we get 32 is equal to k. So y equals k divided by x becomes y is equal to 32 divided by x. Then it says evaluate f of 64. So we're going to use this function that we just came up with and see what number do we get out if I plug in x is 64. So my equation y equals 32 divided by x becomes 32 divided by 64, which is equal to 1/2 or 0.5. So just take 64, plug it in for x, and see what value you get out from the equation. And that's it for Learning Target 6.2.3. Finding a specific direct or inverse variation function, and then you might also be asked to take a different number and plug it in for x just to practice using the function that you've come up with.